Okay, Math 8. So today's lesson is all about interpreting linear relations in kind of these like real world scenarios. So this comes near the end of that work package that I left you. You're going to find, I believe there's 4 different graphs, and you're going to be asked a series of questions about each of those graphs. So when you get to that point, make sure you take out these notes and use them to kind of guide your thinking as you're answering those questions. So we're just going to go through one graph in this lesson, but it's going to take us a little bit to kind of decipher and answer each of these questions. So this graph is titled The Weight of a Jar with Marbles. And so what that means is we're taking an empty jar and we're adding marbles to it. And as we add marbles, we're going to be monitoring or recording kind of the weight of the jar and those marbles. And so you can see that it's a linear relation. As the number of marbles increases by a constant amount, the weight of the jar and the marbles in them is also going to increase by a constant amount. They're in proportion to one another. So the first question asks us to identify the slope of the line. And so this is very similar process to what we've been doing with more of our simple graphs. We know that the slope of a line is simply rise over run. And in this particular case, it's a positive slope, which makes sense because obviously the weight of that system is going to increase as you add more marbles. So as the number of marbles increases, the weight of that system of the jar and the marbles inside it also increases. Now let's just look carefully at our axes for a moment. What you'll notice is on our x-axis, so that's kind of our run axis, that we're actually increasing by 10 each time. And you'll notice that on our y-axis, our rise axis, that we're not increasing by 10, we're actually increasing by 20. So that's different from the graphs we've been looking at previous, where we've just been increasing by 1s on our x's, on our x-axis, and 1s on our y-axis. Now we're jumping numbers. So you need to be careful because that's going to impact how we calculate our slope. So let's go and take a look what that means. So we're going to start with our rise over our run. And we know in order to figure out slope, we need to pick 2 clear coordinates on our graph. I'm going to pick this coordinate, and this coordinate is actually at 10 on my x for the number of marbles and 40 on my y. In other words, when I have 10 marbles in that jar, the jar and the marbles combined weighs 40 grams. I'm going to pick one more point, one more clear coordinate, and I'm going to pick this one right here. And that's at 30 and 100. In other words, when we have 30 marbles in a jar, the system, the marbles and the jar combined, weigh 100 grams. Now let's figure out our slope. So to figure out our slope, we are simply looking at how much we have to rise and how much we have to run to get from the left point to the right point. In this particular case, it is positive. So let's do our rise first. So we are making 3 jumps. And so you would think that our rise would be +3. But what we actually have to recognize is that our y-axis is no longer going up by 1s. Instead, it's going up by 20s. So each jump that we make is actually worth 20. In other words, the total rise that we make is 20 plus 20 plus 20, which actually takes us to a +60. Now, if we look at our run, we're making 2 jumps. But again, our run is not +2. It's actually going to be, well, look down here, each jump is worth 10. So our total run is actually going to be a +20 because 10 plus 10 is 20. Now, what about our units, though? We forgot about our units. So let's go back to our rise. Our rise was 60, but it was being measured in grams. It was a weight. So we had 60 grams. And our run was 20, but it's actually the number of marbles. So it's being measured in marbles. So this is 60 grams per 20 marbles. Now, we can reduce this. We can clean this up. And we know that 60 divided by 20 is going to leave us 3. But what's our unit? Well, our unit is going to be grams per marble. So in other words, what that means is each marble weighs 3 grams. So therefore, each marble, each marble weighs 3 grams. And that's our rate of change. So as we add 1 marble, we're adding 3 grams. If I were to add 2 marbles, we've just added 6 grams. If I were to add 3 marbles, I would have added 9 grams. Now let's look at the y-intercept. Oh, and we'll try to kind of box that answer too. Okay, now let's go down and let's look at our y-intercept. I'm going to do the y-intercept in a different color just so it really stands out on the graph. So I'll do it in red. So the y-intercept is where the graph crosses our y-axis. And so we know that this is our y-axis, the vertical axis here. And where does that line cross the y-axis? Well, it crosses it right about in the middle. I'll actually just erase kind of that mess that I just made. So the y-axis is right where the graph crosses that, or the y-intercept is right where the graph crosses that y-axis. So it's right about there. And to me, it looks like it's about halfway between 0, the bottom line, and 20. So it's about 10. It's an approximate. Now, what does that represent? Well, what that point represents right here is it's actually the coordinate would be 0 and 10. It's 0 on the x-axis and it's 10 up on the y. So in other words, 0 marbles, but we have 10 grams. How is that? What does that mean? Well, that suggests then that the jar itself must be those 10 grams. So therefore, the jar weighs 10 grams. So when there are no marbles in it, we're still getting 10 grams showing up on our scale, which means that the jar just must weigh those 10 grams. So now let's write our equation. And we will just use x and y for our equation for this one because they've left x and y on our graph up above. So we know that our standard equation is y equals mx plus b. So our y is just going to stay as our y. That would be the weight in grams. Our m is going to be the 3, so 3x. And then the b is the y-intercept, so plus 10. So that's going to be the equation that we end up getting. And then the last two questions are asking us to do some interpolation. So in other words, we're going to be using the graph. We're going to be looking at data points within that graph to kind of answer some questions. So how does a jar, or how much does a jar with 40 marbles weigh? So let's go, and I'm just going to pick a different colored pen again. We'll work in yellow on this one so it really stands out. So we're wondering how much 40 marbles, a jar with 40 marbles weighs. So we're going to find 40 on our marbles axis, the x-axis. And when we get there, what we're going to do is we're going to do some interpolation. So we're going to scroll on up, and I'm just using kind of a dotted line until I hit our linear equation, our linear graph. And then I'm going to scroll across, straight across, until I hit my y-axis. And you can see that my point on my y-axis for the weight would be approximately halfway between 120 and 140 grams. So halfway between 120 and 140 is 130. So therefore, the jar with 40 marbles weighs 130 grams. Now, you could also do some algebra, but when you have a graph, it's easier just to kind of interpolate off the graph. The last question then, how many marbles are in a jar that weighs 160 grams? So I'm going to pick one more color. Oh, let's do purple. Why not? We're going to go up. Whoops, way too far up. Let's go back down a little bit. Now, we're wondering how many marbles are in a jar that weighs 160. So we're going to find our weight axis. And you can see it only goes up to 140, but it's going up by 20. So we know that the next line is going to be 160. So I'm going to go across on the 160 until I hit my line. And you can extend the line if you need to a little bit. It's going to hit it right there. And then I'm going to zoom down, dot down, and that's going to tell me how many marbles. So when the jar and the marbles weighs 160, there must be 50 marbles inside that jar. So therefore, there are 50 marbles in a jar that weighs 160 grams. Okay, so that kind of gives you some idea of how to interpret those graphs. The big takeaway, folks, is recognizing what slope represents, and that you need to include the units in these kind of interpretive type questions. It also helps us explain what the y-intercept is. So be careful when you're interpreting those graphs. Make sure you understand what the graph actually represents. And good luck finishing the rest of that assignment. I should see you tomorrow. Thanks, guys.